All right, moving into section 5.4, looking at our last conic section, which is the hyperbola. The geometric definition of a hyperbola is said to be the collection of all points in the plane, the difference of whose distances from two fixed points, called the foci, is a constant. This is very similar to the definition of an ellipse. The only difference is we are now going to be subtracting our distances, whereas for the ellipse, we were adding them to get our constant, okay? So if you click on illustration number 1 there, it should take you to something that looks like this. The blue curves together make up my hyperbola. It's almost like two parabolas combined together to be thought of as one graph, okay? And I have this random point P on the upper half of the hyperbola, and I have points A and B. They represent my focus points. And I'm, of course, showing the distance from each of those focus points to point P, as well as the difference of those distances. Right now, the difference is 2 units, okay? Notice that as I change the location of point P on the curve, see how the distances change, but that difference between them does not. Still always 2 units, okay? Now, a hyperbola has a lot of characteristics on it that are similar to the ellipse, but also a lot of differences, okay? So notice that a hyperbola has 2 focus points, 2 vertices, and 2 covertices, just like the ellipse. Now the difference is your focus points on the hyperbola are further from the center than the vertices are, which is the opposite of what it was on the ellipse, okay? On the ellipse, we had a major axis and a minor axis, all right? For the hyperbola, we still have the same concepts, we just have different names for them. So your transverse axis is a lot like the major axis. The transverse axis, it passes through the vertices, the foci, and your center, okay? And then instead of the minor axis, we have a conjugate axis, which is the axis that passes through your covertices. So right now, my conjugate axis is the y-axis, and my transverse axis is the x-axis in this picture, all right? I also want you to notice that your covertices, which are these points here and here, they are not actually points on the hyperbola, okay? But they're still really important because if you notice, I have this blue rectangle drawn in, and the blue rectangle is formed using the vertices and the covertices, all right? And if we can draw that blue rectangle, it leads us to the asymptotes of the hyperbola, which are those red lines that you see there. And if we know the asymptotes, then it helps us see exactly how wide or how tall each half of the hyperbola is, all right? Also notice there's a lot of symmetry with the hyperbola. It's symmetric with respect to the transverse axis, the conjugate axis, as well as with respect to the center, okay? One final property, the difference that's calculated from your distances to each focus point is always equal to the length of the transverse axis, all right? Now let me illustrate that. If you click on illustration number 2, open that up, should take you here. All right, so your transverse axis, its length is from vertex to vertex. That's represented by the blue line segment there. And then, of course, we're using the green and red line segments to show the distances from each point to your focus points. So what this is going to illustrate is that if I take the difference of the larger distance and the smaller distance, that result is going to equal the length of the transverse axis. Okay. All right, now let's start looking at the equation of a hyperbola. It looks very similar to that of an ellipse. It's right here, with one major difference. Notice we now have subtraction in between the two fractions. Okay, so that's your indication this is a hyperbola and not an ellipse. Notice you still have a squared and b squared in the equation. And the values of A and B are going to represent the same things. Distance from center to your vertices is A. Distance from center to co-vertices is B. All right. Now, this equation represents a hyperbola whose center is the origin and whose transverse axis is along the x-axis. What tells me that is the fact that x is in the numerator of the first fraction. All right. So I'm no longer focusing on my denominators to lead me to, the major and minor axes. Instead, it's more about the numerator that's in the first fraction in front of the subtraction. That's what matters. Okay. Also notice C is going to lead me to my values for my coordinates for my foci, which is the same as it was for the ellipse. But since the foci are now further away from the center than the vertices and the co-vertices, we now have this property that says your C value is larger than A and B. All right, well, that's extremely important. If C is larger than A and B, then it changes the equation that we use to relate A, B, and C together, okay? This is the new equation. B squared equals C squared minus A squared. That's the reverse of what it was on the ellipse, okay? The other thing I want you to notice, if you look in the picture here, look at your asymptotes. Your asymptotes will have equations of y equals b over ax and y equals negative b over ax. Really simple way of determining those is just by using the values for your vertices and your co-vertices, right? A and B give you your vertices and your co-vertices. They're also going to give you the slope of both of those asymptotes, okay? All right, so let's get right into an example here. I want to come up with an equation for a parabola centered at the origin where the focus is at -3, 0, and the vertex is at 2, 0. So let's plot what we know. I'm not going to make a full graph, but I'm gonna plot what I know to help me visualize and reason everything out for the equation. So here's your center, here's your focus, and here's a vertex. So notice that all of those are lining up along the x-axis. That's my transverse axis. Okay. My A value is 2 units, distance from center to the vertex. That'll lead me to my other vertex at -2, 0. My C value is 3, distance from center to my focus point, and that leads me to my other focus point at +3, 0. All right. Use B squared equals C squared minus A squared, which is 9 minus 4. And that gives me B squared to be 5. So once I know B squared, I can make my equation. It would be x squared over my A value squared, which is 4, subtracted by y squared over 5, my B squared value, and that's going to equal 1. And just kind of give you an idea of the behavior of this hyperbola. This isn't completely accurate, but we know it's going to be opening to the left and to the right. Okay. All right. Second example. Analyze x squared over 9 minus y squared over 4 equals 1. So I can tell that's an equation for a hyperbola because of the subtraction there. And analyze for the hyperbola means find the center, find the transverse axis, the foci, the vertices, as well as asymptotes and graph. All right. So right away I can tell you center is the origin. I can tell you the transverse axis is the x-axis. Okay. That's because x is in the first fraction there. All right. My a value is 3, which leads me to my vertices. My vertices are along the x-axis, so they'd have to have coordinates of plus or minus 3, 0. And then my b value would be 2. That's just the square root of the second denominator. So that gives me my co-vertices, which would be at 0 plus or minus 2. All right, and then I'm going to come up with my c value so I can reason out my focus. So b squared equals c squared minus a squared. That's 4 equals c squared minus 9, or c squared equals 13, making c the square root of 13. And remember, my focus points should be along that transverse axis. So they're going to have coordinates of plus or minus the square root of 13, 0. Okay, so that's a little bit smaller than 4 units to the left and to the right of the center, placing me right about here, right about here. Okay. All right, so at this point, what I'm going to do is I'm going to draw in the rectangle that passes through the vertices and the co-vertices. Okay. And that's going to then lead me to my asymptotes associated with the hyperbola. So the asymptotes, they have to pass through the center as well as the vertices of the rectangle. So your asymptotes are going to be doing something like this. It's a little crooked. All right, and once you have those asymptotes drawn, it just helps you be able to sketch out the hyperbola and make sure you draw it to where the ends of the hyperbola, they hug the asymptotes, but they don't actually cross through it. They're getting infinitely close to the asymptotes. Okay. All right, so we finished off the graph. Now the only thing left to do is give the equation of each of the asymptotes. And to do that, you just need to think of the slopes of each one of those lines. And to find the slopes, just pick 2 points on the line. The easiest would be the center point and then a corner of the rectangle. So to go from the center point to the corner, you're rising 2 and you're running 3 to the right. So the slope of that line is 2/3, which means this has the equation y equals 2/3 x. For the other line, the only difference is its slope is going to be negative 2/3. Okay. All right. Now, what if I want to make my equation have its transverse axis along the y-axis? Along the y-axis. Well, now I have to place my y variable in the front. Okay, in the first fraction. That's my indication we're now along the y-axis. But other than that, everything else is the same. A squared is underneath that first fraction, and then b squared is the denominator of the second fraction. Okay, so one final example. Find an equation of a hyperbola having a focus at 0, 6 and vertices at 0, 2 and 0, negative 2. So let's go ahead and plot those. 0, 6, 0, 2, 0, negative 2. Notice that I am lining all those points up along the y-axis, so that's my transverse. Okay. And I can tell you that my A value is 2, my B value is 6. Use those to find my C value is 6. Distance from center to the foci, right? And I guess I kind of skipped over that. Isn't the center going to be the origin here? It's got to be halfway between the two vertices that we're given, right? Okay, so b squared is equal to c squared minus a squared. So that's 36 minus 4, or 32. So b is going to equal the square root of 32, which simplifies to 4 radical 2. All right. So my co-vertices would have to have coordinates of plus or minus 4 radical 2, 0. So let's plot those. Those are a little bit smaller than 5 units to the left and to the right of your center. Then the other thing I need my second focus point, which is down at -6, 0. Okay. So at this point, I can come up with my equation. Since my transverse axis was along the y-axis, I need to put y squared first over my a squared value, which is 4, subtracted by x squared over my b squared value, which is 32. Equal that to 1. All right, there's the equation. And then why don't we finish off the graph here as well? I'm going to draw in my rectangle. And then that's going to lead me to my asymptotes. And this time the hyperbola will be opening up as well as down. This one's a really wide hyperbola. All right, now equations for the asymptotes. All right, so if I use the center point as well as that upper right point on the rectangle, I'm rising 2 and I'm running 4 radical 2. So that means this is y equals 2 over 4 radical 2 times x, which wouldn't want to leave it like that. So I'm going to rationalize it. If you multiply the top and the bottom by radical 2 to rationalize, that's going to take you to 2 radical 2 over 8, which then becomes, of course, radical 2 over 4. So the final asymptote equation should be this. And then for the second one, just change the sign on that. Okay.